low security risk associated with the future vulnerabilities, because we did everything we could do during the code quality efforts. And plus, we also try to measure attack surface and reduce it. Then we are probably more protected than we were protected, in the past. So the fact is, if you cannot measure something, it's not only valid for your software, right? If you cannot measure something, you can't improve it. So we really need to have some kind of measurement and metrics. And metrics in the area of security is very difficult. I mean, it's a really challenging task, right? That's why the research questions I was asking at the beginning, they are really difficult to answer. But I think with the efforts around attack surface measurement, so we came, a few steps closer to the answer. And so we have to do, more and more research in this area, I think. So how do we do this? So in the next 30 minutes, I'm going to present you the abstract attack surface measurement method, and I will talk about instantiation for Java and a case study we did at SAP Research, and also implementation. So I'm trying to give you a kind of intuitive feel, how you can measure the attack surface and what it means in a concrete application. So if you are interested in more details, because we have lots of formal techniques which are explained in the papers, so just contact me and then you can look at the papers. So, okay, what is the intuition behind the attack surface? So consider a system. A system always lives in an environment, right? So we have the system surface, and the system interacts with its environment through the system surface. So this is a kind of abstraction. So a system's attack surface is the ways in which an attacker can enter the system and potentially cause damage. So the question is now, what are these ways? Of course, methods, channels, right? The attacker needs to connect, access the method through a channel. This could be a kind of TCP socket, for example. And data, untrusted data items, right? The system may send some data to its environment or read some data from the environment. If you look at how the attacks happen, SQL injection, cross-site scripting, other kind of things. So I think all kinds of attacks, happen around this principle. They either use channel and then access a method and then send the data, or your application reads the data from a file, but the file already includes some malicious code or data, etc. So this is how it works actually. So, okay, but the important thing here is, you have resources in your software, but not all resources are part of the attack surface, right? So I think the naive way will be to say, you know what, I count the number of bugs I find and then reduce them and then say, okay, my software is now more secure. We really need to look at the code. We really need to look at the sources, because if the software causes security problems, we really need to understand our software and then see what kind of resources are contributing, how much. What is the damage potential associated with each individual source? So, so the interesting resources are the resources that the attacker can use to send data into or receive data from the system, and that's why we need to identify the entry and exit points. These are the methods and other things like channels and data items, etc., so that we know, which resources are more relevant than others. Another thing is, not all resources contribute equally to the attack surface. Right? If you have two methods, the first method runs with the root privilege, and another method runs without root privilege, and if the attacker somehow finds the chance to attack the first method, he can probably cause more damage than he can do when he will attack the second method. So that's why we need to compute the damage potential effort ratio for each resource. And the higher the damage potential, the higher the contribution, as I said at the beginning, and the higher the effort, the lower the contribution. So these two aspects are very important, right? Which resources are important and how much is their contribution. Okay, so let me now introduce the abstract attack surface measurement method. So what we do is we first identify the set of the methods, entry, exit points, channels, and untrusted data items. So M, C, and D representing these things respectively. And we estimate each relevant source's damage potential effort ratio, and then compute the attack surface measurement. So it is the sum of, if I know the damage potential effort ratio for each individual method, then I have a number for all of my methods. If I know the damage potential effort ratio of my channels used in my application, then I know the contribution of the channels to the attack surface of my application, and the same thing applies for the data items. So this is the abstract methodology, and let's now see what we did. So this methodology has been actually refined, developed and refined at Carnegie Mellon University. So the original idea is actually coming from a paper published in 1975 from Zals and Schroeder. So they have been talking about secure design principles. And Michael Howard from Microsoft developed a kind of intuitive approach, pragmatic approach about attack surface measurement, and Carnegie Mellon researchers, Janet Bing and Pratush Manatata, formalized the methodology and also validated it in different systems. So we wanted to understand what this methodology means in the context of enterprise applications, because the previous work was validated in the context of C, C++ based code. So we wanted to first understand what does it mean, for SAP applications, or middleware technologies written in Java, and how can we demonstrate that the method scales to enterprise software. And we also wanted to investigate the possibility of integration with SAP's software development lifecycle. So this was the goal of the collaboration, and we took a middleware component, which we call now here service. So what we did is actually we developed a methodology. It's a kind of instantiation of this abstract methodology for Java, because if you want to apply this abstract method in different languages and environments, you have to really adjust it a little bit, tune it to the language and also its application environment. And so we started this collaboration last year, and I mentioned that there are three types of resources: methods, channels, and untrusted data items. So in our case study, we focus on the method dimension because in the application we choose, there was only one communication channel. There was only one TCP socket, and the service we were analyzing didn't use persistent data. That's why we focus on the method dimension. So for this, we had to identify the entry points and exit points of the service, of the application, of the code, and also estimate the damage potential effort ratio using the method's source of inputs. So I mentioned entry point and exit point. So what's an entry point? What's an exit point? So an entry point is a method that receives data items from the system environment. An exit point is a method that sends data items to the environment. So how did we identify the entry points in Java? So we look actually at the different interfaces used in the application. So M is a method in S as a system's public interface and receives data items as input. So we look at at which kind of methods we should look. So we look at the methods in the public interfaces, and which receive data as input. And M invokes a method in the interface of a system, right? Because if you consider a method actually, so it may also call another method in another system, and plus it may also call some system libraries, Java I/O library methods, for example. This might be, for example, read method in the Java I/O data input stream. So we look actually what the method is doing if the method is an entry point. If the method is an exit point, we look at the methods, of course, the method sending data into, as a result. So, and methods, invoking a method in the interface of a system S and receives data items as input, and also methods invoking interfaces in the Java I/O library. But in this case, the method is using a write method to write something, because the method wants to store something in a store.